Pennsylvania, when people think about animals which live in our freshwater habitats, the first creatures which come to mind are often fish, frogs, turtles, ducks, and geese. These animals are large and common, making them visible to many who venture outdoors. Herons, beavers, and muskrats are also often seen. But there is a group of small aquatic creatures which many of these larger animals rely on. They play an important role in the food chain and help us measure the quality of our waterways. These are the macroinvertebrates, and in this video, we'll explore how they benefit both the environment and people. To start off, we should ask, what is a macroinvertebrate? Let's take a look at the meaning of this word. Macro means large. The opposite word is micro, meaning small. The macro in macroinvertebrate tells us that we are talking about animals big enough to be seen without help from a microscope. However, this doesn't mean macroinvertebrates are large creatures. In fact, many of them are only a few millimeters long, often being less than an inch. This leads us to the second half of the word macroinvertebrate. What does invertebrate mean? Let's break this word down further. Vertebra is another name for the bones of our spine. This means that the word invertebrate has something to do with an animal's backbone. The prefix in actually means without in this case, even though you may think the opposite would be true. So putting these two definitions together, we get a meaning which says without a backbone. Invertebrates are animals which don't have a backbone or skeleton inside their bodies. So what kind of animals have no bones? Remember, these animals are tiny even if we don't need a microscope to see them. Macroinvertebrates include insects, many in their larval or nymph stages, but some adults as well. Other macros which are common in our streams and waterways are mussels such as freshwater clams or crustaceans like our more than 30+ species of crayfish. There are also members of the annelid family, the soft-bodied worms, living in our aquatic habitats. All of these animals have adaptations for life in the water, and many can tell us important things about the health of our water resources. What is it about aquatic habitats that requires special adaptations for macroinvertebrates to live there? Being small means that macroinvertebrates can get washed away by fast-flowing waters, so many of them have evolved methods of dealing with water currents. Some have flattened bodies and the ability to cling tightly to surfaces such as rocks or leaves. This body shape allows water to flow past them and makes it harder for currents to catch a hold of them. When not avoiding currents, some macroinvertebrates have evolved the ability to use jet propulsion to move through the water. They pump water in and out of their bodies to rocket themselves forward. Other macroinvertebrates, mostly the beetles, have lightweight bodies which can run across the surface of the water without sinking, using the surface tension to their benefit. And still other macros, like freshwater mussels and the numerous aquatic worms, can burrow into the mud, silt, and sand at the bottom of a stream, avoiding both water currents and predators in this way. When they're not working to avoid being washed away, macroinvertebrates need to eat, just like any other animal. No matter what species they belong to, all macroinvertebrates fall into one or more feeding categories. These categories include shredders, collectors, scrapers or grazers, and predators. Shredders eat the leaves and other vegetation which falls into our waterways. They are messy eaters and create plenty of crumbs which collectors can then catch and eat. Some collectors filter the shredders' crumbs out of the water with their mouths, while others create little nets or webs, similar to a spider, to catch their food. The next feeding group, the scrapers and grazers, feed mostly on algae which grows on rocks, wood, and other submerged surfaces. And predators feed on other living creatures. Predatory macroinvertebrates can grow to be bigger than other macros, some reaching several inches long. They have been known to eat things like minnows and tadpoles as well as other macros, making them top predators in their little world. Some of them, like dragonflies, are top predators both as nymphs and as adults. In addition to these four feeding groups, some macroinvertebrates are also considered to be scavengers, eating whatever they come across that is already dead. Regardless of what they eat or how they eat it, Macroinvertebrates act as a food source for larger predators such as fish, which then become food for larger fish or other animals, including herons, ospreys, eagles, otters, and people. Some macroinvertebrates, which only live in water during their larval stage and transform into flying adults, also become a major food source in a food chain. Macros such as mosquitoes, mayflies, caddisflies, and craneflies are eaten by migrating and nesting songbirds. Sorting by feeding categories is not the only way that macroinvertebrates can be grouped. Different species have different responses to pollution in the water. Some can tolerate some pollution, others are very sensitive to it, and there are some in the middle, labeled facultative, which can live with a little bit of pollution, but not as much as pollution-tolerant species. This means macroinvertebrates can tell us a lot about water quality. In order to study macroinvertebrates and learn from them, we need to be able to find them. Many types of nets and other equipment have been created to help scientists catch macros living in our waterways. Some equipment is taken out to study sites each time scientists want to do a stream survey. The best times of year to do such surveys is in the spring and the autumn, when the most number of species are in their larval or nymph stages. Other equipment is designed to be left in the stream for extended periods of time and is checked at regular intervals. Over decades of study, we have discovered many things about the relationship between macroinvertebrates and water quality. And the most important thing we've learned is which species can only be found in clean water. Because of such research, we can now measure the health of a stream based on what is living there. Macroinvertebrates give us a better measure of water quality than testing chemical factors. Macroinvertebrates hatch from eggs and will be present in a waterway for many days to months to sometimes years before climbing out of the water as an adult or coming to the end of their lifespan. Chemical tests, though, give us a single snapshot in time, telling us only what is happening in a stream at the exact moment of water sampling. In comparison, macroinvertebrates can tell us about the health of a stream in the recent past, as well as in the present. Macroinvertebrates are easy to overlook when we talk about what lives in our aquatic habitats, but they play an important role in those habitats. Their place in the food chain helps to feed many of the larger animals, which we think of first when we are asked to name freshwater species. So the next time you venture outdoors to visit a stream or lake, see if you can find some of these important creatures. Remember that they are tiny. Check for them clinging to the underside of rocks or branches to avoid water currents. See if you can find any of the shredders eating leaves which have fallen into the water. Or look for beetles and water striders walking across the water's surface. They may be tiny, but once you know where to look for them, you will find that macroinvertebrates are everywhere.